Hello and welcome to the Magic of Material and Technology project. This episode is brought to you by Michael, East Clan, Trenhard, Fenn and Duran, the man, Gonzalez. Today we will take an in-depth look at one of biomedical science's fascinating frontiers. Ghost organs. The first simple organisms evolved some 3.77 billion years ago. Since life came into existence, millions of modifications have been made, and as a result of all these changes, life has followed different blueprints via evolution to reach thousands of different organisms, one of which is us. The human is like the Rolls-Royce of the animal kingdom. The systems that make up the body are, simply put, sophisticated soft machinery that all work in harmony. But what happens when your soft machinery breaks down? And instead of a superior sports car, your body begins to resemble a '98 Honda Civic. Sometimes parts need to be replaced. Organ transplants have been in practice since the first skin grafting procedures were done almost 3,000 years ago, and as our understanding of science and the mechanisms of the human body have increased, it has the ability to transplant more sophisticated organs with greater success. One of the ways larger organs are transplanted is with ghost organs. Ghost organs are the frontier of biomedical research. The idea is to take a donated organ, remove the donor's cells and replace them with the host's own cells. This is done by performing a series of buffered washes to remove the original cells while keeping the extracellular matrix intact, and use that as a scaffolding for the host stem cells. The extracellular matrix has a wide composition, but the main elements that can be found elsewhere are collagen and elastin, two proteins that are found in everyday foods such as jello and kale, and other uses such as ballistics gel used to simulate human body parts. The extracellular scaffolding is then primed for the introduction of its new host stem cells through the process of directed differentiation, where they turn on and knock down specific genes to fit the function of cardiac cells. The cells that proliferate after differentiation all contain the DNA of their new host, which will eliminate the possibility of organ rejection and the need for immunosuppressants. Even with the advent of immunosuppressants, the possibility of organ rejection is still very high. That's why in the early 20th century scientists successfully invented synthetic hearts in an effort to combat the long waiting list for heart transplants. However, these synthetic organs were prone to failure, and in many cases only extended the life of the recipient by a few years at best. Since a ghost heart is composed of the recipient's cells, the possibility of rejection is decreased exponentially. Collagen is manufactured by the body through a complex biosynthetic pathway. The pro-collagen I complex is a triple helix and undergoes several tweaks with local proteins and amino acid chains. The final product is mature collagen. First, the donated organ is collected and washed with a solution to remove the old cells. This process is known as ligma and can take several days. Stem cells are harvested from the recipient and are grown on the extracellular matrix, similar to how a chia pet is grown. Organs have the potential to fetch a pretty penny. The human heart, if in good condition, could be worth around $1 million, and the liver about half as much. If ghost organs become a mainstay in the medical community, then the sale of organs could become one of the most lucrative trades of all time. Ghost organs could have major ethical impacts going forward. When you think about it, humans die because of wear and tear on body systems, similar to how a '98 Honda Civic dies after 450,000 miles. Ha ha, feeble humans. Ghost organs could be grown in order to keep individuals alive well past their original life expectancy. At this point, where has science drawn the line? Should people be allowed to play God in this way?